Okay, so now we will cover next coding exercise. So on the Leetcode, so let's go to the problem section. And in the search, so let's search for the valid mountain. So the problem no 941 valid mountain array, and it's come under the easy category. And it's really an easy question. So in this question, what let's read the question. Given an array of integers array, return true if and only if it is a valid mountain array. So we have to check whether the given array is valid mountain array or not. If it is valid, then we need to return true. If it is invalid, then we need to return false. That's it. But what is valid mountain array? So how the mountain look likes? So if you see the mountain generally look like first it goes on top, then it goes on below. Like then the stairs go upward, then it go downwards. So this looks like a mountain only, right? So as an example, so this let's suppose this is an array 0, 2, 3, 4, 5, 2, 1, 0. So if you see 0, 2, 3, 4, 5, so the numbers are increasing. So the numbers are increasing, right? Doesn't matter whether it is increasing by 1, 2, 3, but numbers are increasing. And at some point, the numbers start getting decreasing. So if this sequence, like if this sequence follows in our array, then we call it is a like a valid mountain. Let's suppose we have the another mountain, we have the another array. Let's check whether it is a like a valid mountain or not. So 0, 2, that's increasing, and then it is not increasing, it is same. Then it is again increasing. So increasing, but this is not increasing, right? And at this point, it is decreasing. But here, this is not increasing. So we can't say like it is a valid mountain. It is not a valid mountain. So valid mountain is there is an array, there is some point, at some point, it could be mid, it could be any point. There could be some point. Before that point, the numbers are in increasing order, and after that point, numbers are in the decreasing order. And the condition is, and along with that, the condition is the length of the array should be greater than 3, because if it is one element, then only it is one element. Then there is no increasing, then there is no decreasing. If there is a one element, then we can say it is a like invalid mountain. If it is two element, let's say 0, 2, so either it's go to decreasing or either it's go to increasing, right? But we need both increasing and decreasing. Then it become a mountain sure proper. If it is only increasing, then it is not mountain. If it is only decreasing, then it is also not mountain. If it is only one element, then it is also not mountain. And if it is like increasing, decreasing like this shape, zigzag shape, then it is also not a mountain, right? So if we have two elements, then definitely it is not a mountain because the numbers are getting decreased. So 2, 1, it is only decreasing. There is no increasing order. So this is not a mountain. So we return false. So let's suppose 3, 5, 5. It is increasing. 3 to 5 increasing, but 5 to 5, there is no increasing. So it is not a like a valid mountain. So 0, 3 to 1, 0 to 3 increasing, then 3 to 2 decreasing, 2 to 1 decreasing. So there is a one point. The point is called 3. There is a one point till which before that the sequence is increasing, and after that the sequence are decreasing. So we are returning true. And our length of the array can be greater than 1. But they have the constant, but it means the user can give the input of array which has length either 1 or either 2 or either 3 or up to 10 to 4. But we know the valid array is the one which has these two conditions met. The first condition is the length should be greater than or equal to 3. So minimum is like 3. So we can, like in our logic, we can put if the length is less than 3, then we directly return false. We will not even going to proceed further, right? And along with that, we have to check like whether is there any point which before that there is an increasing sequence and after that there is a decreasing sequence. So how to check like the increasing sequence? So it's very simple. Like we will start running a loop and we will check with the previous element. So as an example, so this is an array given. we have to check whether this is a valid mountain or this is an invalid mountain. So there are two conditions, whether the length is greater than 3. Yes, the length is greater than 3. One condition is satisfied. There are three conditions, whether the length is greater than 3. Yes, the length is greater than 3. So first condition is satisfied. The second condition, is there any point before which all the elements are in increasing order? So how to check whether all the elements are in increasing order or not? And it could be any point, but it should not be the first and it should not be the last point, because if it is the first point, then after that all are decreasing. If it is the last point, then all the elements are increasing order, there is no decreasing. But so there should be any point, it could be 2, 5, 8, 4, to any point we have to check. So how to check? We will start a loop. We will start a loop from 2 and we will compare 2 with 0. So 2 should be greater than 0, that is perfectly okay. Then we will check the next element. 5 is greater than 2, that is perfectly okay. Then we will check 8. 8 is greater than 5, that is okay. Then it's come to the 4. 4 is not greater than 8. So we found a point. We found a point 8 where, like before that, all the till this point all the elements are in increasing order. So we find a point, then we will run one more loop because we found the index, and we want after this index all the elements should be in the decreasing order. So start from loop here. So this element should be less than 8, that is fine. Then check for the next. 2 should be less than 4, that is fine. 0 should be less than 2, that is fine. So we can check. So only like what like how our code logic looks like. If length of array less than 3, then we can directly return false, because it is not, because if it is one element, then it is not an mountain. If it is two element, then it is not a mountain. If it is three element, then there is a chance that it could be a mountain. All right, so we can directly return false. Otherwise, what we can do is, like in the else condition, what we can do is we can run a loop. So we can run a while loop, uh, like till end. Like we can run till end only because we don't know where that particular point exists. All right. So we can start from I is equal to 1. Let's suppose from the first point. So we have to run a loop from I is less than length of array. All right. And there should be two conditions. Till what point we have to run the loop? Till if array of I is greater than array of I minus 1. If it is matching, then what we will do? I is equal to I plus 1. We will check the next element. So basically, we will start from here, from the first element, because if we will start from here, that is the first element. If the 1 is less than length of array, fine. If this element is greater than the previous element, then we will proceed further. Then check next. If this element greater than the previous element, then we'll proceed further. That's why we are increasing I is equal to I plus 1. If this element is greater than the previous element, then we'll proceed further. Now come to the I this point. Whether this element is proceeding with greater than this element, no. So our array breaks. So our I is right now this at this point at 4. So which is index 0, 1, 2, 3, 4. So I is 4. So I is 4. Then we will check if, because it could be the reason. Let's suppose our array is like this: 0, 1, 2, 3, 4, 5, 6. Then our I will reach here. But this is not a mountain. So once this loop will end, we have to check one condition. If I is equal to 0, that is I is the only first element. All right. So it is not even started. Anyhow, we are starting from the I is equal to 1 only. So I is equal to 1. So which means it is not even going to start. No, I is equal to 0, I think. So basically, if I reaches at end point means if I is equal to length of array. After one loop itself, if I reaches at the length of array, it means it is not a mountain. Then we are going to return a false directly, because we reach till end. There is no decreasing point, all are increasing element, then we are going to return false. So that is this scenario. So let's delete this. But in this scenario, our I reaches till this point. All right. Then we have to check the decreasing order because our while loop finish here because there is no condition met. Then we will check from while. Then again we will check till end only. While length is equal to our end. But this time we will check whether array of I is less than array of I minus 1. So whether of I, where what is I is for, I should be less than the previous element. If that condition met, then what we will do? I is equal to I plus 1. That is, we will check for the next element. So first we are checking for the 4. So 4 is less than 8, fine. Then we'll proceed further. 2 is less than 4, previous element, that is fine. 0 is less than 2, that is perfectly fine. All right. So if I reaches at like if I equal to length of array, it means it reaches till end, then we will return true. We will return because we have checked all element, right? So this is very simple question. Like they have mentioned, okay, this is a valid mountain array, and we have to and we don't know where the point exists. All right. So what we will do, we will just run a while loop, and we will keep checking, keep checking, keep checking, keep checking, and we will found some index where some condition falls, and we get that index, and from that index we will keep checking the decreasing element, and our loop should end till last only. All right. When both the condition are going to meet, then it is called a valid array, and otherwise will called as a like the invalid array. So let's try this question. So from type in import list, let's try this question. Okay, so print solution dot valid mountain array, and we have to pass array, and let's array should be, let's try for 2 1. 2 1 is very simple. Okay, let's do one thing, let's copy all the arrays, and we will test one by one. 2 1 3 5 5. Right. So how to start? So first condition is if so let's calculate the length. Length is equal to length of array. All right. So we know if length is less than 3, we will directly going to return false because then it is not a mountain. All right. Then what we have to do, if length is not equal, if length is greater than 3 or equal to 3, then we are going to start from the first element. That is the first element, not from the 0, because if it is from 0, how we will check on the previous element? Right, then we have to check the next element. So better like check the previous element. So we will check from the first element like 2. So while, and we have to check till end because we don't know where is the breakpoint. So while I is less than length of array, and till what point we have to run a loop? When when the loop is going to break. So when the loop is going to break, when array of I, the current element is great, when we have to run a loop when the current element is greater than the previous element. So if the current element 2 is greater than the previous element, 3 is greater than the previous element, 4 is greater than the previous element, 5 is greater than the previous element, till we will continue going to run a loop. Like, so as soon as we reach this point, we will check, okay, we reach this point. Are we reaches like, is we reaches at the end? Because if we reaches at the end, then like this is not a mountain, this is only like 0 1 2 3 4, that is the array. So we reaches at end, let's suppose, then it is not a mountain because after that there should be some point, there should be some decreasing order. So if I equal to length, then we are going to return false. All right. But let's suppose if I did not reach at end. So what next? So what we have to do? We have to start checking for the decreasing element. So while whatever I is, because I we are doing the I plus one. So I less than length of array, I less than length of array, and array of I should be less than array of I minus one. Just opposite side. First we are checking the greater, then we are checking the net. If that is the case, then we will keep checking I is equal to I plus one. And if I equal to length, if I reaches till end, even cross the boundary, cross the array, then we are going to return true. Right. So if I reaches outside the array, like we are keep checking, then I come here, then I plus one. So I become out of index. So our loop end. So if we reaches till the end, then we have checked the all the decreasing element and it's the value movement. But if I reaches only one or I reaches only zero, then we are not some condition might false because we are not reaching out still outside. Right. So simply that's like what we are doing. We are just checking the increasing order and we are checking the decreasing order. That's it. All right. So then we are going to return true. So now we have to run this on the Leetcode. So let's try. One more condition we need to check if I equal to 1 or I is equal to length, because let's suppose our array is like this. Array is equal to 10 and then 5 and then 6 and then 3 and 2, or 10, 5, 6 and 3, let's suppose. So we have started from 1, we have started from 5, and we are checking with the previous element. So 5 is not equal to the previous element, like 5 is not less than 10, right? 5 is not greater than 10 because first we need the increasing element. 5 is not greater than 10. So our I is still at 1, right? So our I is still at 1. So it means we even not found the increasing order, right? Even it's starting itself, we find the decreasing order. So that's why I still on the 1. If I still on the 1, then we have to return the false. Or if it is not even started, or if it is started, it reaches the end. If it is not even started, or if it is started, it reaches the end. In both the condition, we are going to return false, because valid mountain is only mountain if it is started, but it stopped at some point, right? But in this case, it is neither started, and if it started, it reaches at end. So let's try this. Let's try this if it's going to work or not. Let's exactly going to try here only. Let's run. Okay, accepted. So let's submit. So our like it has been as like accepted, and we have beat 53% of the people. Like it's run in 304 millisecond, and the percentage of memory, it took some memory, but we have not used any memory. So maybe some variables extra. So like what I think is like how we can even more optimize it. We can remove this condition, like or let it be, because why I said that we can remove this condition, because if I is one, only one element, and okay, then no, we need this condition, so let it be. So yeah, that's it. Like that's the end of the video. So it's like easy question, you can also try, and it's a like a good question. Like if you click on the companies tag, it looks like it asks in like multiple companies. So we just need to check only three conditions, and whatever the condition, we will just first make a pseudo code like this, and then we will like implement in our language. Like let's suppose we are using Python, we will implement in the Python. So the only three condition: first is array should be greater than 3 or equal to 3. So we implement it. If it is less, then we return false. The other condition is there should be some point, and that point should be not the first, not the last. There should be some point in between. Before that, there is increasing element. After that, there is a decreasing element. Then we call it as a valid mountain. So we check. Okay, there should be 1 point. So let's start with the like first index. So and then we will keep checking, keep checking. So if we found increasing element, and then we will check. Okay, whether it is going to started. If it is not even started, then it means we have not even found the uh, any increasing order. Or if it reaches till and it means only and only increasing element exists, then we are going to return false. Or if it reaches at some point, then we are going to check whether there is a decreasing sequence or not. So if if our like which keep checking, if our I becomes equal to length, it means we have checked all the like elements, then we keep return true. Otherwise it will like going to return false. Okay, so that's it. So that's the end of the video. Thank you.